Here we'll talk about the remainder theorem. The question asks us to use the remainder theorem to find if x equals 3 or x equals negative 3 is a zero of this polynomial, and if it is, use synthetic division to factor it. The remainder theorem says that if we have an x that we suspect could be a root or a zero of the polynomial, we can simply plug it into the polynomial and see if we get an answer of 0. Let's try this with our polynomial. In all the positions where we see x, we will replace that x with a number. However, according to a previous video, we found that none of the possible negative rational roots could be solutions based on the lower bound theorem. This means, based on our previous work, we can remove x equals negative 3 from consideration. However, we can prove that x equals 3 is a root using the remainder theorem. We're going to replace all of our x's with positive 3. In the parentheses, we will write 3. Then we'll do the arithmetic. 3 to the third power is 27, times 2 gives us 54. 3 to the second power is 9, times negative 9 gives minus 81. 12 times 3 will give us 36, and then we subtract 9. If we combine the positive numbers, 54 and 36, that will give us 90. If we combine the negative numbers, negative 81 and negative 9, that will give us minus 90. And 90 minus 90 gives 0. This means that 3 will be a root. Now to factor the polynomial with synthetic division, we will place that 3 in our box on the upper left when we do synthetic division, and write down each of our coefficients in order starting from highest power to lowest power. Begin by bringing down the 2. If we take that 2 times the 3, we will get positive 6, and negative 9 plus 6 will give negative 3. Then we'll take that negative 3 times the 3, giving us negative 9. 12 minus 9 will give positive 3. Then we take that 3 times the 3 on the left again. 3 times 3 gives 9, which gives us 0. The 0 tells us that the 3 is a root. Since x equals 3 is a root, in order to get the factored form, we'll start with x equals 3 and move the 3 to the left side and change its sign from positive to negative. So we'll end up with x minus 3 equals 0, and this will be our linear term. Then we will look to our synthetic division solutions to find the irreducible quadratic piece of this factored form. We can see that we have 2, negative 3, and positive 3 as our solutions for each column. The number in the last column will become our constant. The number in the next column to the left will become our first power coefficient. And the number to the left of that will be our second power coefficient. This means our irreducible quadratic term will be 2x to the second power minus 3x plus 3. To write this in factored form, we'll put it in parentheses. In our next video, we'll factor this a little bit further.